I'm not Mr. Mapalala, the first disclaimer, but as I've been introduced, I am Umzwandile Magagula, who will be co-hosting or facilitating with Ugajeni. So thank you so much to Dr. Pali for the message of support. And part of what he alluded to towards his conclusion is that we've got Mr. Mjalifa, who will then be able to share with us what can be done to assist with the crisis that we are facing currently as a country. So I'm going to kindly ask if we can just put our hands together for him and welcome him so that he can walk us through what can be done.
Thank you very much. Today, Mr. Pali, you said I should use 10 minutes of his time. Mr. Gaston Pretoria, I'm one of those who ran away during the struggle. I ended up settling in Toronto, Canada. But home has always been on my mind, which is why I'm here, basically. Well, I won't waste any time, but thank you for the opportunity. The idea is that energy is the fulcrum of revolution. We're talking of industrial revolutions, we're talking energy, not technology. We're talking coal. When it was discovered, it led to people looking at ways of harnessing it. And then we started that industrial revolution with the steam engines. Then we found nuclear energy, which gave rise to a totally new science. We have nuclear medicine, we have radiopharmaceuticals, we have all sorts of things. In fact, we had it here, but the moment we were about to take over, the whole thing was dismantled, our capability, our nuclear capability. In fact, I was one of the black people who started working there, and I saw it with my naked eyes being dismantled, the Atomic Energy Corporation. It's now called Nexa, and it's a shadow of what it is. And all along, that was part of the engineering to put us in the periphery of the economy. The economy that Dr. Pali alluded to would benefit a few. And we seem to have stepped in those boots and can't get out of that. And we have our kith and kin in the periphery. And yet we are unable to bring them into the mainstream. And I agree with Dr. Pali that it's only energy that can energize that revolution. We are at the crossroads of making a decision. What energy? Is it solar and wind, or do we continue with coal? In fact, the idea is we should harness energy in the air, just like Nikola Tesla dreamt. We have lots of energy in the air that we can use and for everybody to have access to. That energy is called cyclomatic energy. It's been discovered, the technology to harness it was discovered about 50 years ago by a Russian thermal physicist, Valery Maistetenko. But that energy, unfortunately the Soviet Union, they militarized the technology from the onset. This represents a model of how that technology works. It's counterintuitive. In thermodynamics, you cannot cool, for example, your wet bulb. I'm sure we are engineers, we should know wet bulb. Using evaporation alone, you have to use vapor compression technology, which is very expensive. You have to have a material, a chemical that evaporates at a very, boils at a very low temperature. And with the technology that arose from the very first invention of the Carnot cycle, let me put it this way. Carnot cycle is an engine, we know that. And an engine is nothing but a device that converts heat to work. Work that can produce electricity or take us from A to B, as in automotives and aeroplanes. If you reverse the process and convert work to heat or lack of heat, you have an air conditioner. So an air conditioner is your engine in reverse. The problem with the Carnot cycle is that it's inefficient because it makes assumptions that are impossible. Infinite sink of heat, infinite source of heat. In the real world, everything is finite. That's why your motor vehicle heats up. because the sink is not that infinite, and you have to cool it, otherwise it will melt, right? Now, Meister-Semco and company looked at the reverse of an engine to say, how can we actually make use of energy that we have in the air, just like Nikola Tesla predicted. And we found out that in the air, of course, we have lots of latent energy of heat. We have kinetic energy molecules going around, and this heat, latent heat, is actually being circulated. They came up with the first perfect example of biomimicry. In engineering, if you can mimic nature, the process or the structures of nature, you can't go wrong. The process of cooling by evaporation has evolved over hundreds of millions of years. So it's perfect. That's a blueprint. So if cooling or air conditioning is the reverse of an engine, we should be able to find an engine that can produce electricity, that can produce motion for us without mining for coal or nuclear or uranium or plutonium or any other nuclear material. Meister-Semco found a device that can actually harness latent heat. Now, the cycle that we're talking about is the opposite of the Carnot cycle. The Carnot cycle gave rise to all the problems we have here because of the inefficiencies. When you buy gas, petrol for 100 rand, you only use 20 rand worth, at most 20 rand worth of your petrol for the motion. The 80 rand goes up in the air as the pollution, heat, waste heat, which is why we're having this problem that has been accumulating for 200 years of that. Now the M cycle is trying to reverse that. We can actually cool ourselves or heat ourselves without any energy from the grid, but from the air. What happens is that this guy mimics a biological process of evaporation. You have air current that accelerates evaporation. Just air current. In fact, by nature, we do that in case when we are hot. Here is a fan. It's not working because I forgot the step-down transformer because we have 220 volts here. Out here, this motor is 110. But we can use this fan to pump air inside. So so let's pretend that it is the fan just pumping in air. And I'm not sure if you're able to protect these thermometers. Are you able to protect them for anybody to see? Maybe it's something that you can look at those at some point. But what we have here is the heated mass exchanger. It is made of alternating channels that are made of dry walls and wet walls. I put water in here so that the dry walls, the wet walls can actually absorb water. The wet walls are made of materials that are hydrophilic, so they actually readily absorb water. And the dry walls are made of materials, the opposite, hydrophobic materials. And they are all composite materials. It's like paper. They are made in one of the Soviet Union republics for now, and I don't even know where. The owner is so cagey with the information. So when you pump air through these channels, the channels in the wet, with the wet walls, that's where your evaporation takes place. Then the wall cools the neighboring dry wall indirectly. So you allow only the vapor and heat taken from the walls to escape, to be exhausted. And then allow the processed air or the product air, the cold air, to come through. In fact, I want everybody you trust here to come and put their hand here. You will see that they will attest that the air is getting cold. If you cannot see the thermometers, because I don't see at the back there, you can see. So that is called indirect evaporative cooling. And it actually defines the law of thermodynamics that you cannot cool below wet bulb with evaporation alone. To cool below wet bulb, you need vapor compression technology, which is very expensive. I saw an article quoting Mr. Public Enterprise, I forget his name, saying that to adapt is going to cost us 450 billion rand or something like that. We don't need that. We can use this technology to replace. We can use this technology to replace the vapor compression technology that we're using now. We can augment electricity generation by cooling the inlet air for the. Do we use the gas turbines? Well, the peakers must be using gas turbines. Or if they use diesel, we can convert those and use gas and compress that air into the inlet and increase the thermal efficiency and therefore the generation capacity to about 10 to 15%. We can cool the air that goes into the cooling towers. We pre-cool it so that it cools the water that comes from the condenser before it goes back to the boiler. And by decreasing the temperature, we're increasing thermal efficiency and therefore thermal capacity, the generation capacity. So in fact, we can build a quarter to half the number of power stations that we have now using this type of technology, getting the energy from the air. No pollution, no refrigerants, which are very hostile to the ozone layer. The only thing that will be moving that comes from the extracted materials would be your fat. Everything else is a plant. Plus, of course, here we are using plastic, but we can use glass, which is safe. You'll ask me, why is this technology not being used worldwide? It's actually being used in the data centers for cooling, west coast of the United States. But the poor Russian guy was not a business person, just like the Kalashnikov guy who made that beautiful weapon that liberated us. They don't make money. Money ends up being made by people who are just after the money, not the people. The poor guy got into a company, made a company with some rich people there. Colorado, you can Google it, Colorado. They started making these air conditioners. The data centers love them because they can save 90% of the cost of cooling. Believe me or not, 90%. Because all you need is less than 10% to run your fan to the water. Energy is free, okay? So when the company was beginning to make hundreds of millions of dollars, an Australian giant called CE International, you know about the HVAC giant in Australia, bought them aggressively. And the old man was given little money without knowing what happened. But then he went on to develop the third generation of the technology. When he tried to commercialize it, the Australians took him to court and said, we bought that patent. And then he won his patent back. In fact, I met him last year because my mother, who was very ill, told me, of what use is your dedication if your own people that you said you're fighting for are dying because of load shedding and so on. She really worked on my conscience, and especially when she went to the hospital, she kept on saying all of that. And then she sent Dr. Padi, and finally when she was last days, she said, come over, we need to talk. But I was coming to see her, and Dr. Padi made me come this morning here to show. Master Telco, before I came here, I went to meet them, and they explained exactly the technology. I couldn't believe it, that you can cool below wet bulb to dew point. You can cool to dew point with this thing. And then I saw it, and we constructed this together. I took it back to Toronto, and it's now here. We are trying to put, in fact, within 2 weeks, managed to put together 14 people who donated about $1.4 million rand. And we got in Master Temple here. It was somewhere, it was all over the place. And we're trying to have a company that will make these HMXs so that we can, in fact, one big property manager here is interested in testing this thing because the people don't believe it. And we are going to build air conditioners for proof of concept. And then eventually we'll probably have this developed here. I know I'm running out of time, sorry, but it's very difficult to explain this and say all I want to say within 10 minutes.